Okay, you're looking at this video and thinking, this looks familiar, but I don't remember seeing it in the valid subnets discussion. That's because we used it in the first video, and I'm going to scroll down here in a moment. We're going to go through 5 examples together and just make sure and master this quick operation of determining the number of valid subnets. So let's go right down to the first one, 15000/13. Well, how many bits do we have set to 1 to begin with in this mask? 13. I mean, they're giving us that. Now we need to be able to look at that network number, 15000. We need to know what class it is and how many network bits we have to begin with. We know this is a class A, and we know that we have 8 bits set to 1 in a class A network mask. So this is all there is to it. You subtract that 8, then you leave 5. That means that someone came in, did the subnetting, and borrowed 5 host bits for subnetting. So we have 5 subnet bits. Now, to determine the number of valid subnets from that, you just raise 2 to the 5th power. And that is 2, 4, 8, 16, 32. We have 32 valid subnets. That's it. 32 valid subnets. That's why you've got to know that chart. That's why you got to look at this and say, okay, I know it's a Class A, and I know how many network bits I have in a Class A mask. Let's take a look at another one, 222.10.10/30. So again, they're giving us the number of ones that are in the mask after the subnetting's done. That's 30. What class network is this? This is a Class C. And a Class C network mask has how many bits set to 1 in it? 24. So someone has come in and borrowed 6 subnet bits for subnetting because they started with a 24-bit mask and then they subnetted out to a /30 mask. So now all you got to do is do 2 to the 6th power. 2, 4, 8, 16, 32, 64. You have 64 valid subnets. Let's tackle another one. 145.45.00/25. Okay, so they were kind enough to tell us how many bits are set to 1 in that mask. 25 of them. So what class is 145.45.00? It's Class B. How many network bits do we have in a Class B network mask? 16. So we have 9 subnet bits. Now we just need to raise 2 to the 9th power. 2, 4, 8, 16, 32, 64, 128, 256, 512. 512 valid subnets. Now I am occasionally asked here, do you need to write out powers of 2, before the exam or during the exam time? Personally, still, I just quickly use my fingers. There's no shame in that. I don't mind telling anybody. That's 2 to the 5th power. I just go 2, 4, 8, 16, 32. I don't even think about it. If you're more comfortable writing it down during the exam, that's perfectly fine. But I'm asked occasionally, well, how high am I going to have to go with that? I don't know that for sure, of course. Cisco does not give me copies of the exam, although I'm still asking. Just kidding. But I can't imagine it going higher than 9 or 10. I think all the examples in my books, I stop at 10. So that's about as high. But you just need to double it one more time to go to 10 bits, which would be 1024. So let's take a look at this one. Uh-oh. Well, we got a 255.192.00 mask. So we got to do a little bit of converting here first. And can you tell by looking at that how many bits are set to 1 in that mask? In prefix notation, what is 255.192.00? Well, let's go ahead and write it out real quick. That would be your first octet because it's 255, and we know what that is. It's all ones. So 192 would be, the first bit would be set to 1. That's 128. The second bit is 64, which gives you a total of 192, so that would be it. I knew we weren't going to make that last one because I raised the font. You don't even have to write those last ones out. Once you get to the end of it, you can stop there and say, okay, the mask begins with 10 ones. So in prefix notation, this would be a /10. So that means we're starting with 10 bits set to 1. Now I need to subtract the number of network bits. It's a Class A network, right? How many network bits do I have in that mask? I have 8. So we have 2 subnet bits. And what is 2 to the second power? 2, 4. Done. You have 4 valid subnets. Let's look at one more example together. This one's a little longer, but again, nothing too tough for us here. First off, we got to convert that mask to prefix notation, find out how many ones we have in the mask. We know we've got at least 16. That's the beginning of it right there. Two octets, both of 255. The third one, though, we got to watch out for. So that would be, the first one would be 128. Then you add 64, 192. Then you add 32, which would be 224. And of course, the fourth octet would be all zeros. With practice, you'll be able to look at that mask and say, I know what that is. That's a /19. And if you don't believe me, keep practicing. You'll be amazed. So we have 19 ones that begin that mask. Now, what class is that, and how many network bits do I have? It's a Class B network, so I have 16 network bits. So that means that I have 3 subnet bits. What's 2 to the third power? 2, 4, 8. Subnets. Sounds like the way Popeye would say it. So we got 8 valid subnets, and that's all there is to it. Whether they give it to you, that mask, in prefix notation, or whether they give it to you in dotted decimal, you know exactly how to attack it. When you have that one chart down, when you know by sight whether a network number is from A, B, or C, and what the number of network bits is in the mask, and it's 8, 16, or 24, there's no calculation needed. You just subtract that from the mask you're given, because remember, I know I keep reminding you about this, but the subnetting's already been done. Then you've got your number of subnet bits, you bring 2 to that power, and you're done. 30 seconds or less with practice. But you knew I'd say that. So again, this is another kind of skill that you can practice 5 minutes here, 10 minutes here. You don't need to block out some 3-hour massive block of time. If you can, beautiful, but real life gets in the way. Practice 15 minutes here, 10 minutes there, and you're gold. I will see you on the next video where we're going to apply a similar formula, not quite the same. We're going to pay attention to one particular gotcha and determine how many host addresses, valid host addresses, we have on each one of our subnets. I'll see you there.